we have creatine phosphokinase, that is for the CK. Then we have lactose dehydrogenase. These enzymes, for the creatine phosphokinase, they are mostly found in the heart muscles, as I was saying. Then we have the lactose dehydrogenase. Now, this is a sketch, or let's say a flowchart of the non-functional plasma enzymes, and then the particular enzymes they are likely to be highly concentrated in. So when we take the liver, whenever there is a damage in the liver, there are certain enzymes that are produced, and these enzymes can be clinically detected. And these enzymes can be clinically detected. So we have AST, which is amino aspartate transferase. Then we have ALT, alanine transaminase. We have ALP, alkaline phosphatase. Then we have gamma glutamyl transferase, that's GGT. Then we have lactose dehydrogenase. Then in the heart, when there is a damage in the heart muscles, there can be a wide range of cardiac enzymes that we can measure, like the CK, troponin, creatine phosphokinase. Then we have CKMB. These MB, they are isotypes, or let's say isoenzymes of the creatine phosphokinase. So we have CKMB, CKMM, CKBB. We also have total CK, that is the accumulation of all the isotypes or the isoenzymes of this CK. Then we have the myoglobin. Myoglobin 2 is also found within the cardiac muscles. Then we have the troponin, cardiac troponin T and troponin I. So these ones are mostly used to determine myocardiac infarction. Lactose dehydrogenase 2 as well. Then AST. So you could realize that some of the enzymes are mostly found or are found in two or more of the major organs that we are discussing. So when we talk about lactose dehydrogenase, you can see lactose dehydrogenase here. We can see lactose dehydrogenase there too. For the lactose dehydrogenase, we have isotypes or isoenzymes. So isoenzymes, they are like isotopes, or let's say in chemistry, or let's say they have the same structural formula or structural marker or identification, but may have different functions. So that is for the isotypes or isoenzymes. So we have LD, we have LD1, LD2, LD3, I think LD4. So these ones have functions. They have similar functions, but the LD1, LD2, the isoenzymes, they have more specific functions. Yeah. Okay, so we can talk about AST. AST, you can see AST here at the liver side. We also have AST at the heart side too as well. Then we can talk about the alpha amylase. So for the alpha amylase, it's mostly found in the salivary amylase or the pancreas. And a rise in this one, we can talk about disease such as acute pancreatitis. When there's a rise in alpha amylase, acute pancreatitis. We can peptic ulcer too can also cause the rise in alpha amylase as well. Then we talk about ALP. ALP is mostly bone specific. So wherever there is an abnormal rise in ALP, we can talk about anything that regards to the bone. We can talk about osteoporosis. We can even talk about leukemias. So when there is a high abnormal increase in ALP, we can shift our mind to that particular side. It gives a prognosis of these particular diseases that are likely to occur. And so that will be it for the ALP. Then we have the skeletal muscles. We have the creatine phosphokinase. The creatine phosphokinase also are found in most muscles, especially skeletal muscles. When there is a high increase in this one, we can talk about the rhabdomyolysis. rhabdomyolysis, breaking down of muscles. We can also talk about anything that regards the muscles, including myocardial infarction, and also there are other external factors which may not be pathological but may affect the increase or the decrease of these non-functional plasma enzymes. So for instance, when we talk about, let's say, pregnancy, in pregnancy, the first trimester of pregnancy affects the release of ALP. So that is a physiological condition such as pregnancy. So alkaline phosphatase activity might rise. ALP ALP activities might rise in case of pregnancy. And also when we talk about age too, so infants, there's a higher activity of AST in neonates. So there's a higher activity of AAT. So all these ones, they are not pathological. They are not pathological, but there is a significant higher increase in ALP as well. Then we can also talk about physiological states, pregnancy. We've talked about age. So we can also talk about strenuous exercise, physical activities. So physical activity. That is when we are going to talk about the CKs, creatine phosphokinases, and these ones are increased during strenuous exercises, etc., etc. And also we talk about sex. So that one we can talk about GGT. GGT is generally higher in males than in females. GGT is generally higher in males than in females. All right. Then, so this will be the last thing. Then we bring an end to this chapter of clinical enzymes. But this is just brief. You can read more about clinical enzymes much into this, but this is just for you to grab the concept of clinical enzymes, so that you will not be difficult when you are delving deeper into the intricate parts of these clinical enzymes, as we will talk in future videos, especially when I'm talking about the liver function text and cardiac function text and etc., etc. So there might be an increase in this enzymatic activity. They are reason for the increase in enzymatic activities. We have extent of cell damage. When there is so much extent of cell damage, these non-functional plasma enzymes are likely to be released into the systemic circulation or into the plasma. Then we have increased proliferation of cells. When the cells become so much, there's an increased proliferation of cells. It can also cause an increase in the enzymatic activity. Then we have increase in the rate of cell turnover or damage in enzyme synthesis. So for instance, if there is a particular protein that regulates the synthesis of these enzymes, when there's a problem with that particular protein, there becomes a overproduction of this enzyme, and that can result in an increase in the plasma enzymes. Then we can have an increase due to reduced clearance from the plasma. So naturally these enzymes are cleared from the system, are excreted, and if there is a problem in the excretion, there can be a retention of these enzymes, and it might be found in the plasma. Then we can have a rate of release from damaged cells. Okay, so although some of these cells, when damaged, some of these cells does not frequently release these non-functional plasma enzymes. Some of the dead cells are engulfed by phagocytes, etc., and all the enzymes are digested by lysozymes or lactic enzymes. But some too, they ensure that these enzymes are released more frequently, and as they are released, they are predominantly found in the plasma. Decreased formation can also be as a result of genetics, acquired, or enzyme inhibition. I believe you've enjoyed this video. You can subscribe more to learn more. See you later in our future videos. Bye.